Ladies and gentlemen, students, faculty, friends of communications, I'm Ed Tiedemann, General Chair of GlobeCom 2015, and it's my pleasure to welcome you to San Diego. The theme of our conference is Connecting All Through Communication, which evokes the Internet of Things, the Internet of Everything, the connectivity revolution that is happening now. I'd like to turn it over briefly to Sergio Benedetto, President of IEEE Communications Society, for some opening remarks from him, and I'll get back to you talking a little bit about telecommunications in San Diego.
Thank you, Ed. Ladies and gentlemen, dear colleagues, it is really a great pleasure to welcome you all on behalf of the IEEE Communications Society to GlobeCom 2015 in San Diego. The Communications Society holds yearly two major flagship conferences, ICC and GlobeCom. The locations are carefully chosen worldwide by ComSoc GlobeCom ICC Management and Strategy Committee, and each location adds to the conference technical program its particular flavor. It is difficult, though, to imagine a better match than San Diego for a telecom conference whose theme is Connecting All Through Communications. This city is not only the host of the largest wireless community worldwide, but it's also been the cradle of wireless telecommunication industry, starting with Linkabit and continuing with the more than 75 direct or indirect Linkabit spin-off companies, including Qualcomm. Now, there are three main reasons to attend one of ComSoc conferences. The technical program, with its blend of symposia, workshops, and tutorials, catering to academic, scientists, industry engineers, and practitioners. The second is professional networking and friendly socialization, with a chance to meet thousands of colleagues to exchange technical ideas and perhaps to start as the basis for future collaboration. The third, and not the last one, is the venue, for which I hope you will have some time before and after the sessions to enjoy the beauty of this vibrant city with its unique, beautiful location. And with this, I look forward to welcome you personally, and as of now, I declare open GlobeCom 2015 and wish you all a most profitable and enriching conferences. Thank you.
Thank you, Sergio. I'd like to start and talk a little bit about San Diego and communications. I'm a wireless person, so I'm going to focus starting on wireless. San Diego was very early in the days of wireless. In 1906, at the end of Point Loma, that's that big spit of land that goes out there that you can see, we started with our Navy station, radio station, Point Loma, 5 kilowatt transmitter. And that was actually the beginning of a lot of the naval installations that are in San Diego. And San Diego is the largest U.S. Navy facility on the west coast of the United States. I think you all can see that with basically more than 60 ships being stationed here. On the right, something that came out slightly later. In 1917, La Cholla's transmitter were built. And for those of you who used to have been to San Diego in the past, these were torn down in 1995. But as you looked out the right side of the airplane, landing in San Diego, you waved to the transmitters. They're about the height of your plane coming in to San Diego. Okay. So, by the way, when those were built, okay, those were a 200 kilowatt transmitter, a huge power, and AT&T specially built tubes for that particular transmitter. It's also very fitting to note today being December 7th. Okay, this being the 74th anniversary of Pearl Harbor, this was the relay point for the news of the beginning of, from the U.S. perspective, the Second World War into the United States. Well, some other things that are more interesting. We used to have and we still do have a large number of interesting things that you can see. We used to be able to look out just from the hotel, a little bit to the south of us, to see the Weber array, this big, large array, which was on the bottom of the Silver Strand. By the way, before you get there, you can see where the Navy SEALs train out there today. Unfortunately, this was just torn down this year, not too long ago. But you can still see, looking out from here, part of the stuff that's on Point Loma and the legacy of the Naval Electronics Laboratory, now called Spa Wars, and you can actually see this antenna test range here, and there are many, many other antenna test ranges that you can see out on Point Loma. But I want to talk to you and turn to sort of the modern era of telecommunications in San Diego. And Sergio alluded to that, and I'm going to show you a slide which you cannot read. And this is actually slightly out of date, being in 2009. But this shows the beginning of San Diego modern telecommunications, which actually started with 3 people who had a Massachusetts connection, but all living in San Diego. They formed a company called Linkabit, and these people were Andrew Viterbi, Erwin Jacobs, and Leonard Kleinrock. About a year after they formed, Leonard Kleinrock dropped out, and then Andrew Viterbi and Erwin Jacobs moved Linkabit forward, and the legacy of that has spawned a huge number of companies in San Diego. In fact, a predecessor of this conference, the National Telecommunications Conference, was in San Diego in 1974 and was chaired by Erwin Jacobs at that time. But if looking at these companies that are coming out, Qualcomm is probably the most well-known, of having somewhere around 31,000 employees at its peak. But many others have made a mark in the industry. It's very fitting that our first speaker, who I will introduce later, first keynote speaker, Mark Danford, is from that legacy, being at Linkabit and then forming ViaSat somewhat later. I'm now going to turn it over to Dilip, who is going to tell us and give us some highlights of the conference. Dilip?
Hi, welcome to San Diego, and hope you have a lot of fun at the conference and even outside. Maybe you take a cruise or go to the zoo. We have a great program for you at the conference. There are over 2,300 attendees and many more signing up real time. We have 8 great keynotes, 2,583 papers submitted, 945 presented, and 24 technical symposia, 23 workshops for you, 32 tutorials, 24 panels, and 3 exec panels, 1 on each day of the 3 main days of the conference. Next slide, please. The exec panels are on when will 5G be real? Another one is on data center networking and cloud computing. And then the third one is on how to build a successful career in communications. It's combined with the IEEE Young Professionals and IF&E dialogue with industry leaders. Next slide. And please do participate. We invite all the young professionals, but also people who would like to engage with them and share their experiences on how to grow. It's for everybody. Please do join in the reception today evening. You have a great set of speakers out here, and you'll have a great time. And please do participate actively in this session. A lot of work has gone into trying to create this networking session, and you will try to find people who are working in areas of interest to you, or you might want to learn about other areas, and you might want to learn about how you might want to pursue a career in this industry. So please do participate today evening. Next slide. And then we also are promoting Women in Engineering with a luncheon panel on Tuesday. And we have a great panel here with Qualcomm, Intel, and Technical University at Dresden, and also an independent board member. So Susie, Patty, Martha, Miriam, and Purnima, they will all light up this panel. And please do welcome for this. You're welcome to attend, and it's not restricted to women. In fact, we would like everybody to participate and encourage women engineers in the industry. So please do come. Next slide, please. And then we have a lightning talk session. This is on Tuesday at 4:15 in the afternoon. And we're going to have Len Redder from JPL, who's going to chair this session. And we'll have 5-minute talks on random thoughts. And perhaps that'll be the next Linkabit and the next Qualcomm, but we don't know. But, just come in and attend this and have fun. And if there are still slots available, you could reach out to Len and try to squeeze your thought in. But be very focused when you talk in this. For all the presenters that are there, you got to be really focused and deliver your message in 5 minutes. Next slide, please. And we have a bunch of conference awards. Normally the conference has technical paper awards. There are 11 regular symposia, and then the special areas of communication symposium. All the tracks, we picked one paper, so the 12 papers, and Ramesh Rao, our TPC chair, will tell you more about it. And then in the industry program, we wanted to encourage all the tutorials and the panels and the workshops that are going on there. So we'll have a bunch of awards for those, and the posters and the demos and so on. And then we have a new committee, the Industrial Conference and Exhibition Committee, and they want to institute another award, so we'll have that as well. So we're now promoting awards in both the technical and industry. And so be very active, all the industry participants in your panel, and hopefully you will get an award. So next slide, please. And before this, I just wanted, IEEE Comstock wanted me to let you know that there's a badge insert which has the program. You could use that. Download also from the web the conference app. And also there's a scavenger hunt, which it's a virtual scavenger hunt that you could download and participate in. And also there are going to be drawings in the exhibits area. And so you have some tickets to drop in there, and hopefully your name will be called out. So we want you to participate in the exhibition, and so please do come and to the exhibits and view all of them. And I'll hand it back to Ed. Thank you.
Thank you. It's my pleasure to introduce Mark Dankberg of ViaSat, who will be our first keynote speaker. Mark is one of the founders of ViaSat, San Diego company, as I indicated before, and coming from the Linkabit heritage. And he has served as CEO and chairman of the company since its inception in 1986. ViaSat has been one of America's fastest growing companies, with around 3,700 employees right now and $1.4 billion in business. It's slightly over twice the size of Linkabit was at its peak. So you can see that the heritage has grown and become very big in San Diego. Mark has his degrees from Rice University, and he is a member of the Rice University Electrical and Computer Engineering Hall of Fame. He is an expert in communications, has authored several military standards on communications. Standards are something, for those of you who know me, are dear to my heart, given my work at Qualcomm and such. And he's been involved in a lot of areas and exceedingly well known in the entire area of satellite communications, and particularly defense satellite communications. I'm not going to stand in your way to hear more from Mark, so please welcome Mark here. and for his keynote. Mark.
Thank you, Ed. Good morning, everybody. And I'd like to give you a little bit of insight into what we believe the role of satellites can be in connecting the billions of people around the world who are currently unconnected and don't have good prospects of being so. Uh-oh. Let's see. Go. So the first thing I always like to do when I talk about satellites is to invoke this quote from Will Rogers, a famous American humorist from the Depression era, early 20th century. And his point is, it's not the things that we don't know that give us trouble, it's the things that we think we know but ain't so. And that is something to remember as we go through this presentation, because I think hopefully you'll learn a few things about satellites and the role of satellites that may otherwise have been quite surprising. First main point I want to make, and you can see I've got this combination of technology and business background, is that today, connecting the unconnected in the world is really an economic problem. Given the satellite systems that already exist, you can communicate from anywhere in the world already. The issue is, how do you do that affordably? And how do you do it in a way that gives people the amount of data and the speeds that they need today to really be part of our society? And this chart gives you a sense of the potential for satellite. What it shows, it's from an analyst firm called Sanford Bernstein, and I used data from 2011 to help make this point. Back in 2011, the TV industry was really more about broadcast than it was about interactive TV. And what this chart shows is the return on invested capital for telecom companies of all types in the United States. So starting all the way on the left, the ones that were the absolute least productive from a return on capital were the wireline telcos. The next, and you can see as a group, that was a very, very difficult industry. Next to worst were the wireless companies. And the wireless companies as a whole were generally, I mean, you can see there's orange is national, green is regional. But the wireless companies as a whole, generally better than the wireline companies, but not as good as that next group, which was the cable companies in the US. But by far, the best return on capital of any telecommunications company in the United States were satellite TV companies. And that was because their infrastructure is so capital efficient compared to any other form of communications that they were able to earn very, very high returns. Now, when you're thinking about trying to connect people and think about, say, the philanthropic element of that, high returns translates directly into the lowest possible cost. So the big question then is, how would you marshal that type of capital efficiency? And you can see the point of this chart is that even the worst of the satellite TV companies had returns on capital that were better than any of the other forms of telecom. The question is, how would you marshal this and apply it towards communications? And the first thing is that people will say is, well, that was easy because it was broadcast, okay? And the thing about it is, when you're thinking about space for broadcast or communications, this is a good way to show it. You need the right tool for the job, okay? And one of the problems that people think about when they think about satellite communications is they're taking a tool that was designed for broadcast and trying to apply it to unicast communications. And for any of you that are involved in any form of wireless, you know, that makes no sense, right? So what you really need to do is, if you want to be capital efficient from space, you need to apply a tool for unicast from space, and that creates the opportunity to have capital efficiency in the unicast and data business that's comparable to what you can get in the broadcast business, which is the best in the world. So the analogy that I make is when you think about broadcast on the terrestrial sense, and we saw some good examples of that just a few minutes ago, you're thinking about towers. Often you'll try to place a tower someplace, a high point, use as much power as you can. But when you take that same spectrum that you applied for radio broadcast terrestrially, and you apply it for unicast, such as through wireless, what you want to do is pretty much the opposite. Instead of using that spectrum one time from a 50 kilowatt tower, you want to have a lot of highly dispersed cellular towers. So the direct analogy for satellite is, instead of having one high-power satellite with a big beam broadcasting the same thing to everybody, what you really want to do is you want to make lots and lots of spot beams in order to get frequency reuse and all the benefits that you would expect from the same thing from doing in the terrestrial world. And this, Australia provides a really, really good example of that, because I'm going to be able to show you a little bit of both the terrestrial and satellite situations in Australia. This is a map from Optus Mobile, and it shows their wireless coverage in Australia. And it makes the point that you can see that they're covering, small percentage, probably less than 5% of the land mass of Australia, and covering 98.5% of the population, right? And what they're doing is they're using, obviously, lots and lots of towers to get both frequency reuse and also to tailor the supply of wireless communications or broadband wireless communications to match the population distribution. Right? That's really, obviously, really, really important principle in wireless. And if you want to make satellite economical and provide all this service and coverage to the unconnected people, we need to remember that same principle. So again, back in the early 20th century, there was this bank robber who became famous partly because of what he said, which was, finally people asked him, why do you rob banks? And he said, well, because that's where the money is, right? So if you're going to provide telecom services to people, you really need to follow that same maxim, which is you need to put your coverage where the people are. And people, and all demands for telecom services in the world are very highly concentrated. And what I'm showing here are just a few different ways of looking at demand. What would, if you look on a map, what would be those things that would drive demand and would motivate you to put your supply where those are? One would be population, that's that top left one. Another one could be air routes, and you look at that bottom left one, which is the green. You could look at GDP, generally where you see higher concentrations of GDP, you'll find a lot more demand for bandwidth and communications. Another one factor, and it is true for both ends of the scale, would be, say, geopolitical stability. That will be concentrated in different ways, and at each end you'll have different needs for communications. So one of the other points about this, when you think about how you solve that problem, and again, this is well understood in the wireless industry, not only is that global population concentrated, and here's a little bit of a 3D view where the more intensity is obviously more demand. You can see it's very concentrated, but it's also kind of a fractal problem. If you were to look at it on a national scale, say in the United States, again, you'll see, especially in the Northeast, you'll see those spikes, very highly concentrated demand. But if you go, say, to a